I'm Okinet. I will introduce the ATS internals. It is a code reading result from our research. So this is the agenda. There is 3 sections, AIO and the DNS and the TransformVConnection. So the first one is AIO subsystem. So AIO subsystem create a AIO IQ request for a file description, and AIO request is a array, a global array. It conceives no more than 100 disks, and the AIO request array is protected by a insert mutex. So, but you can look up the array without acquire the lock. So only the insert need to obtain the lock. There is 8 thread for an AIO request, and you can change it by the config item proxy config catch thread per disk, and atomic queue AIO temp list in the AIO request structure. And there is a sort queue AIO to do. Priority, it always saving the IO task into the HTTP AIO to do. There is a diagram for the task queues lookup and create and insert. So we can see AIO IQ requests into the array. You need to open the insert mutex log. Oh, sorry? Point array. Point array is defined by this line. It's global. Sorry, I didn't modify the code, just research. So for AIO request structure, ATS create a thread group, AIO thread group, and it is a dedicated thread. And the AIO subsystem has a AIO loop. The AIO loop is blocked by one of the following 2 operations: when you read and write disk, or blocking by conditional wait. Therefore, each AIO loops consume only one AIO task from the queue, and create multiple AIO threads support concurrent IO operations on specific file description. For example, the block device. So this is if you have one raw disk, we can create at the max moment 8 ETAIO thread. This is 0 and 1, 2, 3, 8. Every AIO task, AIO request structure has a atomic queue. This is the atomic queue. It receives the new IO task into the saving to atomic queue across the thread, and loading the atomic loading the I/O task from atomic queue into the sorting queue. The sorting queue has a sub queue, HTTP I/O to do. It's always saving the lowest I/O task. It means priority is 0. And all the thread consume the I/O task from this sort queue one by one. This is a loop. I will introduce the loop in the next slide.
I have a quick question.
Okay.
So what sets the priority on the operations?
What?
What sets the priority on the operations? Like,
how many
like what's an example of different priorities?
You mean the maximum priority?
No. Why would something be? Why would one AIO request be prioritized over another AIO request? Can you give me an example of why we would do that? Like if you had 2 cache reads or something like that, I would assume that they would have the same priority. When does something get one priority over another? You know? Do you know what I'm saying?
Yeah. Sorry.
Maybe you can. Can you explain it differently? You're not getting what I'm saying.
Oh, sorry. Okay, so there's a priority that determines the order of these things. Do you know any piece of code that actually sets the priority to anything other than 0?
Mm-hmm. As far as I can tell, the priority bigger than 0 not used in ATS.
Okay. That was his question.
So in the current, we're only using the priority is 0 because it's HTTP AIO. You can read it, you can understand about the name. I guess the AIO to do with the priority bigger than 0 is used to the streaming cache. Maybe RTSP and MMS protocol.
Yeah, that was all ripped out. Yeah, I was wondering though, I'll have to check, if the cache, if you're doing evacuations, you might want to bump the priority of that up, right? When the right cursor and you're doing evacuations, those should be done before any other cache operations. I wonder if that's used there.
Okay, let me continue. This is details in the thread loop. So this is a dedicated thread start. The loop has 2 parts. One part is locked part. It means this internal sorting queue is locked. There is a lock here, and unlock part. In this part, the mutex is unlocked. So, but it block here. It will be blocked here to read and write the disk. And this is another block. It's a conditional wait. When the ARO queues, the queues is empty. When it is empty, we will block here to wait a new incoming IO task. So the loops is going to move. Move means the loading the IO task from from the atomic queue into the sort queue. It's moving. Pick up only one IO task from the sorting queue. When IO thread got a new IO task, it unlocks the mutex and reading or write the IO task into the disk or read from it, and then call back the state machine to inform the IO operation is complete and going to the next loop. Okay, next is native IO. So we know the native IO is supported by Linux kernel and the glibc. Native AIO is very similar to the ePro system. For example, IO setup vs ePro create. It also create a native AIO the handler. IO get events vs ePro wait. It's a polling IO ready event. IO submit vs ePro CTL. It submit the IO request to the Linux kernel. And in the ATS, we will have disk handler and net handler. This is details for the native AIO APIs. So we can see the CTX is vs the ePro FD. And gets events. We create a handler and get events from the handler. The returned events means the I/O task is complete, and you can get it from the result. We loading the events into the structure, just like loading the FD into ready list. Like net handler, we have a ready list. So this is compete to the ready list. And moving ready list, this is the internal queue, ready list, to receive I/O task from the local thread. And submit the new AIO request into the local array. And submit the local array by I/O submit to the kernel. This is a new loop for the native AIO. It's just like the ePro operation. It's very similar to net handler. This handler is also in every ET-net threads, but it's different from net handler. This handler bundled to its thread. It shares the mutex with its E thread. So we have net handler and disk handler in every ET-net thread. The disk handler has an I/O task queue, the ready list. It is a local queue, accessed from current E thread only. The level of current I/O operations is controlled internally by native I/O. So kernel controls the concurrent to the concurrent read and write to the disk. So we have ET-net, one ET-net, two, and more ET-net. In the ET-net, we have disk handler. Here, disk handler. And the state machine initial AIO read and write operation by inc AIO read and write API, and create IO task and enqueue the task into the ready list. It's a local queue, so without lock. And the ready list is loading into the ready list and dequeue into the local array and submit the local array by I/O submit into the kernel. So the kernel doing the I/O read and write operation, and we get when the I/O operations complete, we get the response by the I/O get events API. This is very similar to the ePro. Okay, the I/O system is finished. The next one is DNS support system.
Actually,
okay.
Do you you go back a slide? Oh. Yeah, so I mean, we've done a lot of work here in the ETNet threads, particularly with the negative events. I've worked on it. I know that, Faye, you worked on that a bit too? Negative events? The problem you have here is that if you're doing native AIO, then you have two blocking calls that you have, one for the disk I/O and one for the network I/O, because ETNet's also doing the ePOL on the sockets.
No. This is not blocking the Ethernet. The I/O task.
Zero timeout.
Yes. Put into the kernel. Kernel will create a separate thread to doing I/O read and I/O write. It's not blocking the Ethernet.
Yeah. But you have to ask us, how does the net thread complete, the kernel thread completes? Does it set a bit or does it send a signal? How does the disk handler here know that that event has completed?
Okay.
So I do an AIO, I send off the read event.
Mm-hmm.
How am I notified that the read event is completed? It's like a poll, right? So
Polling.
Yeah.
It's
so when you call that poll function from the ETNet, is there a zero timeout on that? What's the timeout on that poll call? Because with ePOL, you pass a timeout to say, well, I'm only willing to wait.
Yes, it's not breaking. You cannot break the wait. What? Wait. Yes, blocking for no, sorry. It's not blocking. It's not blocking.
So in effect, it has a...
Yes, this is the timeout time is 0.
Okay.
Timeout is 0. It's only return the ready. It only return the complete I/O task.
Right. So you poll with the zero timeout. So if there's nothing,
zero timeout wait.
If nothing is finished, you just go on.
Yes.
Okay.
Yes. So there is a difference for ePOL wait. ePOL wait has a timeout more than 0. Yeah. So this is a timeout time is 0. So next is a DNS subsystem. DNS subsystem has a task queue, and the task queue has two types of the entries. One type is a pending entry, and another is in-flight. New queries and retry queries will be pending entry. DNS subsystem will create an unique query ID for each DNS request. Once DNS request is sent, it will be set to in-flight. So we can look up them by domain name. So any pending entry could be looked up by domain name. In-flight entry, DNS request without response. So we send a request. Before we receiving the response from DNS server, it keeps in in-flight mode, in-flight state. We can looking up the in-flight entry by name, by domain name, or by the query ID. In the DNS entry, we have a duplicate queue. Duplicate queue shares DNS results for tasks which looking up for same domain name. In order to send a duplicate request to the, in order to avoid sending duplicate DNS request to server, it saves duplicate task. Traverse dupes queue and callback continuation one by one. This is a loop. It's the DNS task queue. It is similar to a table. For the different rule, has a different domain. As the one row, the entries in one row has a safe domain request for DNS. When we create a DNS looking up request, it first look up the first entry in every row to finding we have a duplicate, whether we have a duplicate DNS request. If we found a duplicate entry, we attach the new entry in the duplicate queues into the duplicate queue. When we receiving DNS result, and we looking up the DNS entry by query ID, and finding out the duplicate queue, and call back the row, call back all entries in a row. There is a DNS connections internal queue, and in the Ethernet thread group, only have one E thread. It's a ETDNS0, and it has two key components: a DNS handler and a net handler. If DNS0 shares E thread with ETNet thread 0, there is a DNS handler also in the E thread net 0. DNS handler bundled to ETDNS. It shares mutex with E thread. The net handler is used to pulling on DNS connection, UDP socket FD. The DNS connection is pulling only on ETDNS0 or ETNet0. The DNS connection has a array. It supports a maximum 32 connections to the DNS server.
Do you have any opinions on whether you should have a separate DNS thread or piggyback on the ETNet?
Sorry.
Do you have any opinion on whether you're better off running with a separate DNS thread or piggybacking on ETNet?
Yes, ETDNS and ETNet can separate.
But what would you recommend? Which do you think is better?
I know the separate mode is not working now.
Oh, the separate isn't working?
Maybe I remember it is not working because the
okay, right, I know what you mean, yes. I think we fixed that though. Because what happened was the continuation would get dispatched from the DNS thread and it would expect ETNet support structures that weren't there. I think was the problem. I think we got that fixed.
I remember. So this one. Okay. This is ETDNS0 and this is ETDNS0. The trigger call enqueue the DNS connection into a triggered queue. Into the trigger queue. If the ETDNS, ETNet and the ETDNS is different, it cross the.
Oh, there's a race condition?
Sorry, no. Let me confirm and answer your question in the afternoon. So the next section is the TransformVConnection.
Ooh, this will be fun.
TransformVConnection is a pipe or a chain that is connected by one or more cont internals. TVC is a unidirectional pipe. The first VConnection internal is the input side. The transform terminals is always attached to the tail as the output side. When the transform terminals receive any data from its upstream, it will send transform read ready event to the owner of TVC. This is a diagram. We can see the pipe. It's a unidirectional, the pipe. We have an input MO buffer and output MO buffer. So the input MO buffer sent to the first VConnection internal by the dual write is sending and saving the pointer into the M write VIO member. The last one always transform terminals. We can write data into the transform VConnections by TVC dual write. The TVC dual write and the TVC shutdown and the TVC dual close is a wrap function for the first VConnection internal. When you dual write for TVC and dual close TVC, actually you dual on the first VConnection internal. And this one, the first connector is upstreaming for the next one. Which upstream. Sorry, the first one is the second one upstreaming. The second one is the first one's downstreaming. So the terminals has upstream from the last VConnection internal. And we can read data from the TVC, TransformVC. Actually, we read data from transform terminals. This also, we do the read operation by dual read. It saves the output MO buffer with the M read VIO. The TransformVC and tunnel chain is working together in ATS. TVC as both a consumer and a producer connecting two tunnels. So we have two tunnels in the HTTP SM. The two tunnels are chained in order to drive the data stream from TVC input to the output. So it is a complete pipe from the source VC to the target VC. This is a full completed pipe diagram. So this is the source VC, and another side is the target VC. There is a socket FD inside the source VC connection, and the HTTP tunnel 0 read the data with dual read from the socket, and saving the data into the input MO buffer, and the source VC will be create a producer in the HTTP tunnel 0, and the TransformVC as a consumer in the HTTP tunnel 0. The data will feeding into the TransformVC and through the pipe to the output, the transform terminals. When the terminals receiving data, or the upstream dual write to the transform terminals, it will send the transform read ready event to the owner, HTTP SM. HTTP SM will initial and create a HTTP tunnel 1 and change the tunnel 1 to the tunnel 0 and receive the data from transform terminals. The transform VConnection as the producer in the tunnel 1 and the target VC as the consumer in the tunnel 1. So it reads the data from terminals into the output buffer and write write out to the socket FD. So okay, this is all. Thank you.
So, is there any possibility of getting some of this into our documentation?
Sorry?
So, these diagrams are nice, but they're just in slides. It'd be really nice if they were in the architecture documentation
Yes.
for traffic server.
Yes.
Okay.
Okay.
Do you have any?
I will share the source file for the diagram.
Oh, what? What?
Yes.
What tool do you use to make the graph?
Omnigram. Okay.
How do you get from this into?
Well, that's a concern. Well, I mean, obviously, the overall thing I would like is to put this into the official documentation, right? That would be good.
But I'm kind of concerned that we should have one way of having these diagrams. We always take the
Plant UML.
right.
Can you export document to
Like PDF.
Well, can you export it to Plant UML? It's actually pretty popular.
I will share the source file.
Can you see what you're going to export? No, it's
OmniGraffle.
Sorry?
Can you load up at an OmniGraffle and see how you can export it from the web?
Oh. 这个，不好意思。
你可以导出很多的内部式的，在那个画图那个程序里面。
这个。
对，然后导出一下，看一下。
Yeah, do a save as.
PDF, PNG, TIFF, SVG.
SVG is probably the best choice. We're going to check it in.
SVG.
Yeah. I don't think we don't want to check.
But here's the concern. I mean, we can translate it to someone, but you can't expect people to have OmniGraffle to edit these files.
Well, the bigger problem is generating them, right? If we check in the OmniGraffle source, when you generate the docs,
That's really good, right?
yes.
We can import like some static stuff, but then we can't edit them. SVG we can possibly edit.
Yeah.
There are some open source SVG editors, but not awesome.
I mean, SVJ is very low level, right? So it's it ends up being very compact for diagrams like this, which are just squares and boxes and things.
I kind of feel that it's worth the effort to, this is awesome, right? But it's worth the effort to move this into TransformVC and your focus very.
I mean, I can look at that, but someone's just telling me I do too much stuff already.
Is there an SVG to TransformVC?
No, SVG is like assembler. It's a nice output for the generators to generate. But, yeah, but you don't want to. It's an output only format.
Okay, I'll share the
Yeah, well, certainly
source
it's-
file to the.
Yeah, when you upload your.
They can.
Yeah, when you upload your slides, you could also upload the at least the OmniGraffle source. That would be good. We need to look at getting this stuff moved into the official documentation at some point. Because it seems a shame to just only do this and just have it one presentation. I'd like something more permanent, right?
So we need something permanent or something like the edit?
Yes. So, but first step is we get the slides and the OmniGraffle stuff uploaded to the wiki in the presentation area. That's clearly step
But
one.
I know of it. You have other diagrams like this too, right? You remember in other summits you show similar diagrams on that. You have other diagrams too that people will benefit from. I remember in the previous summits you showed some other diagrams.
Yes.
Right. It would be great if we get all of these.
All this. Okay.
Yeah, all of them.
Oh, no problem.
Everything. Yeah.
Yes.
Yeah, we could look at, I don't know, how hard is it to install OmniGraffle? Can we get a command line tool? It's one of the reasons we picked PlantUML is that it's easy to get a command line tool that we can download automatically, right? You can put it on bin tray, you can download the jar, you can run on the command line and generate the stuff, right? That was one of the big features of PlantUML.
But that's not going to be the case with.
Isn't it? How do you know?
Commercial tool. We can't expect it to.
Oh, I suppose there's that. Anyway, we might want to talk about that this afternoon, but we should look at this. This is a lot of work that would benefit a lot of people to have around.
Right.
Yeah, and also the understanding about this diagram is the understanding of code can be translated to English and the language to the official government. So basically, all the code is actually not contract in the example like the official government.
No problem. I need your help, actually. Okay, that's all.